Hi everybody, welcome to Shel lectures. So in this video we'll be talking about ionic equilibrium. So before getting into this chapter, we have to know some basic formulae based on logarithm which has to be used in this lesson. So the first thing is log x. Whenever you find something like this, log x to the base e, it means 2.303 into log x to the base 10 or 2.303 into log x. It's itself understood. Though there is no 10 as base, it's understood that log to the base 10. And if log x into y, it means log x plus log y. That is, addition of both of the quantities will give you the multiplication. And also log x by y is equal to log x minus log y. And here log x power y. So the power will come to the front. So y will come to the front, it becomes y log x. So log 6 can be written as log 2 into 3, log 2 plus 3. Log 30 can be written as log 3 into 10, log 3 plus log 10. Log 1000 can be written as log 10 to the power 3. 3 should be brought to the front. Then it becomes 3 log 10. That is 3 into 1 is equal to 3. So here also we have been given with some values of log. Log 1 is 0. Log 10 is 1. Log 100 is 2. Log 1000 is 3. All the other values are not much necessary, but it's better if you learn them. But log 1 is equal to 0. Log 10 is equal to 1. Log 100 is equal to 2. And log 1000 is equal to 3 are very important. Then we have to know about antilog, which means antilog of any quantity is equal to 10 raised to that quantity. For example, antilog of 2 is 10 raised to 2, that is 100. Antilog of 0.3010 is 10 raised to 0.3010, which is 2. Antilog of log 2 is 10 to the power log 2. So that's nothing but antilog of 0.3010, because log 2's value is 0.3010. You can find it out here, 0.3010. So antilog of log 2, the value is being substituted here, 0.3010, and in the previous step we found out that that's 2. So this is all about the logarithmic scale. And then we also have to know about the pH scale, which was introduced by Sorensen. So pH scale is also known as Sorensen scale. That's actually a scale used to measure strength of acid and base, and its value is equal to minus log bracket H plus. Okay, so what is pH scale? It is actually a scale which is used to measure the strength of acid or base. Okay, it is used to measure the strength of an acid or base, and its value is equal to minus log H plus, or it can be written something like this. pH is equal to minus log concentration of hydrogen ions. pH is equal to minus log concentration of hydrogen ions. For instance, if it's 10 power minus 3 is hydrogen ion concentration, then you can write pH is equal to minus log into 10 power minus 3. The minus 3 when brought to the front becomes 3 into log 10. So log 10's value we have learnt it as 1. So 3 into 1 will give you 3. Now let's do it with pH is equal to x. Then you will be getting H plus is equal to 10 power minus x. Okay, this is just a conclusion. For example, here pH is equal to 3, and what is H plus? 10 power minus 3, right? So if pH is equal to x, then H plus is equal to 10 power minus x. And what is POH? That's nothing but hydroxyl ion concentration. So that formula will be POH is equal to minus log into OH minus ions concentration, hydroxide ions concentration. Okay, so here you have been given with a general problem which we will be looking at later. So this is what is the pH scale at 25 degrees Celsius. So if it's 7, that is if it lies at 7, if the pH value lies at 7, it's said to be neutral. And before 7, all these parts 1 to 6 account for acid, and 8 to 14 account for base. Okay, so you can just remember A, B. A comes first and B comes next. This is the strongest acid, 0, 1 and all accounts to strongest acid, whereas 1 nearby neutral is weakest, and after that weakest and then strongest. Okay, so here when you go, the strength of acid goes on increasing, and here when you go, the strength of base goes on increasing. So according to the conductivity, we know this very well. Non-conductor, those which do not show, exhibit electricity, that is, they do not allow the passage of current through them. Example, non-metals, plastic, rubber and all, you can't expect current to pass through these substances, so they are non-conductors. Only one exception is graphite, which is a non-metal, but still it conducts electricity because of the motion of free electrons. Generally, non-metals don't conduct electricity, but one exception is graphite. When we talk about conductors, those which allow the passage of electric current through them, they show conductivity. There are two types of conductors, metallic, the word itself says metallic. So the motion of free electrons is what brings out the thing here. What is free electron? Actually there will be the nucleus and the electrons will be surrounded. So some electrons which are in the valence shell will be loosely bound to the nucleus. So they will just move out of the nucleus, move out of the atom, and they will be traveling around. So that kind of electrons are known as free electrons, and if those free electrons move and they bring about electricity in a particular substance, that is known as a metallic conductor. Example, all metals, graphite, which is the only non-metal which is a conductor. Then when we talk about ionic conductors, the word itself says ionic. So here the conductivity, actually the passage of current is actually shown due to the movement of ions. Okay, there we talked about free electrons. Here we must talk about free ions. Okay, ions are actually in the free state, but when you pass electricity, what happens is the ions move towards the oppositely charged electrodes. Okay, for example, cation. What is the symbol of cation? Cation, when you write cation, you write it as CAT, right? So there is a plus there. So cation is positive, so it moved towards anode. Okay, cation move towards cathode, because cathode is the negative electrode. Okay, cation is positive, so it will be moving towards the oppositely charged electrode, that is cathode. Cathode is negative, but cation is positive. And then anion moves towards anode. So due to this reason, what happens? The current flows through the solution due to the movement of these ions, and that is why conduction takes place. Example for this is AgNO3. Okay, there Ag is the cation and NO3 is the anion. So they move towards the ions, like silver and nitrate move towards their oppositely charged electrodes. Okay. Then we have to know about strong electrolytes. Strong electrolytes are ones which completely ionize in aqueous solutions. That is, when you add such electrolytes to water, they'll completely get ionized. That is, they'll completely get separated into a cation and an anion. Such things are known as strong electrolytes. So the degree of ionization is 100%. That is alpha. That is the constant. Dissociation constant is equal to 1. Purely it is 1. So the degree of ionization is 100%. That is 100% ionization takes place. So what are the examples? Strong acids like sulfuric, nitric, hydrochloric, perchloric, okay, all the hydrobromic acid all comes under this category. Also strong bases and all salts come under strong electrolytes category. Then you know about weak electrolytes. They are partially ionizable in aqueous solutions, like weak acids like hydrogen cyanide, acetic acid, formic acid, all these, and weak bases also, ammonium hydroxide, zinc hydroxide, iron hydroxide, all these are weak electrolytes, and their value of alpha is less than 1 because the degree of ionization is not purely 100%. Then we have to know about Arrhenius concept. So what is Arrhenius concept? Arrhenius concept tells that when an electrolyte dissolves in water, it split up into two oppositely charged particles. That is, I told you earlier that cation is positive and anion is negative. Whenever you put such an electrolyte into water, what will happen? Immediately it will split up into two oppositely charged particles, cation and anion. Okay, so total positive charge is equal to the total negative charge. In any electrolytic solution, the total positive charge is always equal to the total negative charge. That is, the electrolytic solution must always stay neutral. But it doesn't mean that the number of positive charges are equal to the number of negative charges. The number of positive ions may or may not be equal to the number of negative ions, but the total charge of the positive must be equal to the total charge of the negative, and then the solution will be electrically neutral. And the properties of the electrolytic solution are also defined by its ions. For example, when you take copper sulfate solution, it's blue in color due to the presence of copper ions. It's blue in color because of the presence of copper ions. Okay, so the properties of electrolytes are also based on the ions. And then when electric current is passed in aqueous solution, what will happen? Cation migrates towards cathode and anion migrates towards anode. This we just now discussed. When a weak electrolyte is dissolved in water, what will happen? I told you that they will not get completely ionized. The degree of ionization is less than, it's not 100%, and the dissociation constant is also less than 1. So an equilibrium will be set up by the ionized moles and the unionized moles. So always there will be some unionized moles also because it's weak electrolyte. For example, if I take a weak electrolyte like AB, it will be giving A plus plus B minus, not completely because it does not get completely ionized. So again this may turn here, turn here, turn here. So reversible reaction, that is, it stays at equilibrium. So for this reaction we can write the equilibrium constant as the active masses of the products by active mass of reactants. How this comes, if you want to know how this came, you can refer to my previous video in my YouTube channel. Okay, thank you so much for watching. Subscribe to my channel if you have not done so far. Like and share this video to whomever you know. Thank you so much for watching.